So we're simplifying radicals with higher powers. We took the square root of 56 is 2 square root 14. Square root of 294 is 7 square root 6. So those were just warm-up questions. And we have one more warm-up question, which is one that has a coefficient. So the question is 3 square root 72. So what would be a factor of 72 that would also be a perfect square? Trying to move this window. Oh, never mind. So what's a factor of 72 that's a perfect square? Roshan? 9 is, but it would be 9 and what? 9 and 8, right? The problem is that 8 has a perfect square factor in it, so we know that 9 is not the biggest perfect square factor. Dominic? 36. Yes, you pick 36 and 2. So split this up as 3 square root 36 times 2. The 36 comes out as a 6, and then you have 3 times 6 square root 2, which simplifies to 18 square root 2. All right, so now we're going to move on to the higher powers examples. Number 4, it's a square root of 18 and a to the 9th. So we're going to think about the 18 as we always have. So we could break 18 up into 9 and 2. And then we're going to think about the variable as what we have in the past too, where if you have a and an exponent, you just write out all of the a's and group the a's together to find out how many you can pull out. So first of all, 18 is 9 times 2. And then we have 9 a's. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember how last week we would take parentheses and put it around our pairs of 9, our pairs of a's. So I put parentheses around 9 since I could take that out, and then put parentheses around every 2 a's. So I grouped together these 2 a's, so that'd be 1, 2, 3, 4. And if I have 4 a's I can pull out of the radical, that would become a to the 4th. But I also have the 3 from the 9, so 3, a to the 4th. And then I would keep the 2 and the other a under the radical. So I want us to think about this a different way that's going to be easier than writing out everything. Because what if I had the square root of a to the 81st power? I'm not going to want to write out 81 a's, right? And then pair up all of them and like count up how many pairs I have. There's got to be an easier way. So here's another way to think about the square root of a to the 9th. We know that anytime you have the square root of a squared, that comes out. So I can rewrite this as a squared times a squared all the way until I get to a to the 9th. For example, a to the 2nd times a to the 2nd would be how many a's? You can just say it out loud. 4. So I need more, right? So that a to the 2nd, that would give me 6. A to the 2nd, that would give me 8. So then I need one more to give me 9. So then each a squared I can pull out of the radical as a to the 4th square root a. Okay, that still seems like a lot of work though, doesn't it? If you have a to the 81st power, what are you going to do then? So here's the next thing to think about it. If I have the square root of a to the 8th power, that's a to the what power? A to the 4th. If I have the square root of a to the 9th, if I want to try to pull that as many a's as I can out of the radical, I would just simply pull out the odd a to make it even. So I would separate a to the 8th times a. Then I could leave the odd a under the radical and pull out the even a's. So the even a's are going to become a to the fourth. The odd a stays underneath. Therefore, if we have a to the 81st power, we just pull out the odd a and make that a to the 80th times a, which would be a to the 40th times the square root of a. Because basically you're just taking 80 and dividing it by 2 because that's what the root is. And then getting a to the 40th. All right, so that's how we deal with higher powers of a variable. So let's do the next one, number 5. I want green, but it's not giving me green. Okay, so we have there we go. The square root of x squared, y to the 7th, and z to the 11th. So if we have an even root, we just have to take that out, that variable out, and divide the exponent by 2. If we have an odd root, we're going to pull out 1 from it to make it even. So I'm going to rewrite the x squared. That's going to come out. And feel free to do any of these steps in your head, okay? I'm just breaking out all of the steps, but I'm sure some of you might be able to just do some of this in your head. And then y to the 7th, I'm going to make that y to the 6th times y. Z to the 11th, I'm going to make z to the 10th times z. And then I'm going to put parentheses around anything I can pull out. So I can pull out the x squared, the y to the 6th, the z to the 10th. When I pull out x squared, it becomes x. When I pull out y to the 6th, it becomes y to the 3rd. When I pull out z to the 10th, it becomes z to the 5th. And then the odd y and z stay under the radical because they don't have a pair. So x, y to the 3rd, z to the 5th, square root, y, z. So kind of weird, but that's how it is. Next question, number 6. A little bit harder. 8x square root 180 x to the 4th, y to the 6th, z to the 9th. So first of all, let's take care of the 180. 180 is divisible by what? Oh boy. Yes.
36.
Yeah, 36 and 5. So I would rewrite it as 8x square root 36 times 5, x to the 4th, y to the 6th, and then the z to the 9th, I would make z to the 8th times z so that I can have an even number of z's to pull out. So the 36 comes out as a 6. So we have the 8x, we have 6. The x to the 4th becomes x to the 2nd. The y to the 6th becomes y to the 3rd. The z to the 8th becomes z to the 4th. And then the 5 and the z stay underneath. Now I'm not done here because I can multiply the 8 and the 6 together. That's 48. And I can also combine the x's. So if I had x squared come out of the radical, but there was already an x there, I can make that x to the 3rd. And then the rest of it, I'm just going to copy down because it doesn't change. All right, next question. Now we're going to get to the cubes. So we'll do the cube root of, and this goes back to question 1, the cube root of 56. But in question 1, we did the square root of 56. So for question 1, we picked 4 and 14. But now what 2 factors are we going to pick if it's the cube root? Yeah, because 8 is a perfect cube. So cube root, 8 times 7, The 8 comes out as a 2. So 2 cube root of 7. Okay, now we'll do an example with a variable. We'll do the cube root of y to the 14th. So remember how we had the square root and we basically wanted the exponent to be divisible by 2. But right now, if it's the cube root, we want the exponent to be divisible by 3. So is 14 divisible by 3? No. So how can we rewrite this so that it is divisible by 3? How can we separate the y? What number less than 14 is divisible by 3? Roshan? What'd you say?
4.
I think you might be thinking too far ahead. I'm asking you just how do you separate the y so that the exponent is divisible by 3? So 4 isn't divisible by 3. Morgan? Yeah, 12. And then if you do 12 divided by 3, you get 4. So we'll separate it as y to the 12th times y to the 2nd, because that would add up to y to the 14th. The y to the 12th would come out as y to the 4th, and then cube root of y squared, which stays underneath because the exponent is smaller than the root. So we would need at least 3 y's to bring it out of the radical. We only have 2 left over, so it stays. So it's kind of like the idea of, you know how sometimes back in like grade school you learned division, and you divide the number, and what's the number that you bring up if it's left over? What's that called? Yeah, so it's kind of like dividing and then you have the remainder. So if you did 14 divided by 3, you'd get 12 with the remainder of what? 2. Yeah, so you can think about that if you want. Okay, another one. We're going to skip that question. We'll do this one. Okay, so 9 cube root of 64 p to the 7th q to the 10th. First of all, 64 is already perfect cube, so that's nice. We don't have to do anything with that. P to the 7th, I would rewrite that as what? Tegan? Times p, yes. P to the 6 times p. And then what about the q? Yes, q to the 9th times q. So the 64 comes out as a 4. The p to the 6 comes out as p to the 2nd, because we're doing 6 divided by 3. Q to the 9th, 9 divided by 3 is 3, so it would be q to the 3rd. And then cube root of pq left underneath. And just one more question that doesn't really have to do with these type of roots, but it will. There will be a question like this that shows up on the quiz. Why? Okay, there we go. Last one is parentheses 9 plus square root x times parentheses 8 plus square root x. So this has a little bit to do with what we did in 3.3, but on the quiz, you won't be tested on the conjugate. That would just be a bonus question. It's requiring the use of the conjugate. But there will be a question that asks you to do this. So what do you have to do here? It wants you to simplify, which means get rid of parentheses. So Roshan? Yeah, you're gonna have to FOIL. So let's FOIL. First, outer, inner, last. So first would be 72. The outer would be 9 square root x. The inner would be plus 8 square root x. And the last would be square root x times square root x, which is just x. I can add up my two middle terms. So that's 72 plus 17 square root x plus x. And then there's no other way you can simplify that, so that would just be your final answer. Technically, you would switch the x in the 72 to be in standard form, but I won't make that matter tomorrow. Okay, so those are your examples today. So you can go to the Edulastic. I know I finally made an Edulastic. I don't know if that's a good or a bad thing, but I made one for your homework. And there is also a quiz review. How do you find said quiz review?